Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great webinar on tap today with some really interesting information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, you will be able to access it on demand post-event. We will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll take about 10 or 15 minutes near the end of the presentation and go through those. Okay, with that, we'll go ahead and kick off today's webinar, which is Don't Fly Blind, Avoid Cloud-Only Monitoring Visibility Gaps. Our speakers today are Mehdi Daoudi, who is CEO and co-founder of Catchpoint, and Ranjana Devaji, who is performance engineer at Catchpoint. Welcome to you both. Thanks for joining me today.
Thank you so much for organizing this, and we look forward to having a great conversation and answer some good topics around synthetic monitoring and end user monitoring.
Excellent. Well, I'm going to go ahead and put myself on mute, Mehdi, and let you go ahead and do your thing.
Thank you so much. Well, again, thank you so much, everybody, for joining. What we're going to be talking about is how to make sure that you don't have any visibility gaps into your end user monitoring. So at the end of the day, as any technology organization, we're here to support our business. And today, the world we live in, the customer experience is the product. So it's extremely important to remember why we are having this call today. It's really about the customer experience, and most specifically, the digital customer experience. So the digital customer experience is defined as the sum of all the interactions that the user can have with your organization through a digital medium. So that can be a call center interaction, but most importantly, a chat or an experience with a website or web application. So it's extremely important. As I said, the customer experience is the product these days. Digital experiences are complex, and they are getting more and more complex. So there are three trends that we see. One is the growing digital business transformation, where companies have to adapt and have to adapt fast. That means that they have to develop and release new software, new application, new mobile applications on a continuous basis. There is also the increasing IT complexity. This is under the iceberg. You can see all the different things that can create a bottleneck to providing a great user experience. And things are getting more and more complex, not less, from multiple CDN implementations to multi-cloud or hybrid cloud, to dealing with public DNS resolvers around the world, to ISP and peering issues, to little micro outages, or to, if you're a global company, how to make sure that governments don't have interferences in your digital delivery. Think about Russia, China, etc. And then you have the growing customer expectations, which is escalating, where a few years ago people would say, well, if a page doesn't load in 4 or 5 seconds, it's bad. Today it's below 2 seconds. My kids tell me that the internet is down if something takes more than 1 second. So this is the world we live in. This is the world we have to navigate, and it's getting more complex. And the internet, we have to remember that at the end of the day, this is a very complex infrastructure that allows us to communicate, chat, Slack, email, shop, etc. And the internet backbone is very vast, and it's extremely important to remember that at the end of the day, as the senator from Alaska said many years ago, it's a series of tubes, and anything can go wrong during that transmission of those packets between the end user and the server or the service delivering that content. So why are we having this call today? It's actually to dispel some myth. We're seeing in the industry a growing trend where basically a lot of the monitoring companies decide to rely solely on vantage points that are hosted on the cloud, where before people or companies would have vantage points spread out around the world on different ISPs, different geographies. Today, we're seeing a regression in the sense of monitoring being hosted only on AWS or on Azure. And so this is what we're going to be talking about, is what are the danger of relying only on a cloud monitoring strategy. So we prepared a bunch of true or false statements just to have some fun. So the first one that we hear is the cloud is more reliable and reduce noise in alerts. So obviously in the monitoring space, alert fatigue and false positive is something that is extremely bad. And so is the cloud more reliable? And the answer is no. And we'll have examples that we're going to share with you around that. Response time from the cloud are faster than from the backbone or broadband ISPs. The answer is actually true. And we'll have some data to show that the majority of the data we've collected over a period of 6 months shows that response time measured from nodes, from vantage points on the cloud, such as AWS or Azure, shows that the response time is much better than if it's measured from where closer to the end user. The cloud can show me that network and ISP related issues. And the answer is no. Because at the end of the day, if you have a node running on AWS, or if you have a vantage point running on any of the cloud providers, it's extremely difficult to have the outbound connectivity and having visibility into which carrier which path we took out of to the end user. Monitoring from the cloud can help with CDN mapping and benchmarking, etc. And the answer is no, however, there as well. Because again, you don't have visibility from a network perspective to really hold some of these CDNs and other pieces of infrastructure accountable. So there is an impact to having a cloud-only monitoring strategy, and this is a very important. So these are the business impacts to having only a cloud vantage point strategy. So one of the things that we've seen customers have is issues measuring their SLAs. If you're on a cloud and you're monitoring from the cloud, it's going to be very hard to hold some of your cloud providers accountable. Today in the news, AWS Korea had to give back 10% to all their Korean customers because of an outage they had on November 22nd. It's also extremely hard to benchmark. To create a good benchmark, you need not only to have the right targets, so you have to compare apples to apples, but you also have to make sure that you are not measuring, if you're not on the cloud and you're comparing yourself to a site that is hosted on the cloud, you're going to be at a disadvantage. It's going to be very hard for you also to validate your third-party infrastructure providers, such as CDN, DNS providers, etc. Why? Because most of them have direct peering with some of those cloud providers. So from a network perspective, some of the networking might look very weird. And then obviously you cannot monitor network and ISP connectivity. And so you have to remember one thing is at the end of the day, end users do not connect to the internet via a cloud provider, at least not yet. So these are some of the problems that we've discovered talking to some of our customers that we relied only on the cloud-only approach. So false positives were through the roof. They also missed a lot of performance issues that were not detected by the monitoring tools. And then the other one, which I think is the most important, is the deceptive performance data, where, and this is a true example that happened last Friday. I was on the call with the prospect, where they relied mostly on the third-party monitoring company that had only nodes on AWS. So the data that the monitoring tool would show was like, hey, the pages are loading in 1.3 seconds, where everybody inside the organization was complaining that the data was a complete mismatch to what they themselves were experiencing at around 13, 14 seconds. So there is a big difference between 1.3 seconds and 14 seconds. So these are some of the biggest challenges we've seen. So this is an example that I'm going to talk about a little bit, and then Ranjana much later is going to dive into some really cool other examples we have. So in this particular chart on the left, so this is a bank that we were monitoring. So they were looking at Catchpoint. So this from a timing perspective was perfect. So they were monitoring their website, and so on the left you have the data that is coming only from our own cloud nodes, so nodes that we have on AWS, and then on the right you have the data for the same bank at the same time coming from our the rest of our US nodes that are on different carriers, different backbone providers, and also different broadband providers. So this particular customer basically went into code red, blue code, code blue, where everything was down, but that was because their monitoring system was on AWS and AWS was having an outage. Therefore, all the telemetry and all the signals they were getting were telling them that they were having an issue, when in fact they were not having an issue. So in this particular case, any AWS glitch impacted their monitoring telemetry. So this is the false positive. I mentioned earlier that how deceptive some of the performance data can be. And so here, this is the result of about 6 months worth of capture, where we tested various websites. And this is just an example with some of the financial companies we've measured. And we looked at DNS time and response time, not the entire web page load, but this is just how long it took to deliver the HTML page to our agents. And so you have the cloud measurements. So this is running from all the AWS and Azure nodes that we have. And then the backbone column is all the nodes that we have running on the level 3s, the Comcast, the Verizons of the world. And so as you can see, all the data that came from our cloud node looked much, much, much better than the backbone, sometimes by a very big factor, right? And so you have to be very careful that sometimes some of the data coming from the cloud node can be very deceptive. So this can impact the decisions you make on capacity, on SLA management, on a lot of things. So in order for you to have a monitoring strategy that is going to eliminate your blind spots, we firmly believe that it's extremely important to monitor from as many vantage points as you can. And so that's why we have been investing over the last 10 years on creating a fairly large network of vantage points. We have about 700 plus vantage points around the world, and they come in different shapes and sizes to really give you that different perspective. So we have nodes on what we call the backbone and the broadband of the internet. So these are strategically placed in the key cities around the world. So we look at cities based on the population, and then we look at data from various sources to determine which ISPs we need to monitor from. So for example, having Comcast or AT&T or Verizon is extremely important, or level 3, as it's one of the major backbone providers in the world. We also have nodes on the cloud. We have about 111 nodes running on all the major cloud providers, and this is mostly to help customers determine which cloud provider is best for them, especially if they still maintain a hybrid environment. You need to make sure that the connectivity between the edge compute system and the hybrid model is best. We have also nodes that you can run inside your enterprise, and those are really great at monitoring SaaS applications that you have, but also monitoring the first mile. Then we have a vast network of what we call last mile agents, and so this is a hardware solution that we have deployed at people's houses around the world that can collect data from that last mile perspective. And then finally, an array of about 50 wireless nodes around the world that allows customers to test and monitor and verify what the performance is and availability is from a wireless perspective, whether it's 3G, 4G, or very soon 5G as well. So it's very important to make sure that you monitor from these different vantage points, because the telemetry is different and it tells you a different story, obviously. And it answers different questions, of course, as well. So these are the reasons why you should use which solution. Again, the backbone broadband comes up as one of the cleanest clean room environment that allows you to monitor from an outside in. It really makes sure that if things don't work from some of the backbone and broadband locations we have, it's definitely not going to work for the end users. Because if you're testing from, for example, Verizon or Comcast, and the majority of your end users are on Comcast or Tata, or China Telecom, for example, then definitely we're going to have problems reaching those end users. It's really good as well to help you compare the performance between different ISPs across geography. So that is extremely important, especially if you're a global company and your goal is to deliver the same great user experience across all your users around the world. So the cloud monitoring, as I mentioned, one of the best use cases is actually to monitor and make sure that there is reliability between the cloud provider you're choosing and your hybrid environment that you're still maintaining. It's also, if you're a full cloud company, it's great to do monitoring as a first mile. So, hey, is it working from within the region of AWS kind of thing? It's also very good to keep track of performance of your third parties that you work with, especially the ones that are also located on cloud providers. So, for example, you're an e-commerce site and you're using an address verification service, and both of you are located on AWS. It's a great way of monitoring the performance and reliability of that service within that environment. And again, it's a great way to monitor and verify performance during cloud migrations. This is something that we see a lot, is customers using our cloud nodes to ensure that from a cloud migration perspective, there is no variability before and after. A lot of our customers use our last mile to correlate the data between the broadband and backbone nodes with the last mile locations. And so another thing that we see is customers using this to really understand the impact of some local ISPs, whether it's net neutrality or blocking, or how some local ISPs block certain things, such as public resolvers, or sometimes when they do DNS hijacking. So it's extremely important to use this from a different perspective, more from understanding, hey, what would happen to my site if I am on the AT&T Uverse and I decide to use Google public DNS servers, for example. And then finally, wireless. I mean, we live in a wireless world. So this is very important to understand which CDN to use, because some CDNs are much better than others on wireless. It's also very good to understand from a networking perspective how far you are from those towers. If you're still on a hybrid environment or a traditional data center, and making sure that you have the right ISPs or the right backbone providers back into your data center. And then finally, enterprise. As SaaS application adoption is rising, it's very important to think about the end user perspective, but now from an employee perspective, making sure that your employees don't have productivity issues because of performance. So I'm going to pass this to Ranjana now, and she's going to go over some really cool examples that we've been able to capture and highlight the need of this diverse strategy.
Thanks, Mehdi. Hi, everybody. My name is Ranjana, and so here's basically starting off with certain examples that we uncovered during our study over the course of this year across multiple industries. We're going to look at some DNS monitoring use cases where we ran into some specific DNS issues across ISPs. We're going to look at how some micro outages impacted multiple websites that we were able to catch only on Backbone. And we'll also look at some CDN monitoring examples that we ran into. Right. So before we get into the specifics of these examples, I'd like to provide some context and start with one of our most powerful test types, which is DNS monitoring. So basically, of the many different parts that make up an online system, DNS is perhaps the most important, right? So it's the very first interaction that a customer has with an online brand. And therefore, having a very fast DNS lookup and resolution process is very important to maintaining good customer experience, right? And DNS has been around for many, many years, but how we actually use DNS has grown and evolved in complexity over the years, and the need for better monitoring is very critical. Right. So with Catchpoint, as you can see on the slide, not only can you basically trend DNS resolution times as a separate network components for the base HTML of a page, for example, or even individual requests that make up a web page. We can also take you one step further and provide you with what we call a DNS experience test, where you'll be able to actually split this DNS resolution process into multiple levels, starting from the top level domain all the way to the point where you actually receive the IP address. And we'll be able to help you trend each of these levels separately and help you isolate issues that might arise out of any of these levels of resolution. Right. And if at any point there is a situation where you've isolated 2 or 3 name servers that cause certain issues, we also give you the power to trend these name server resolution responses separately. So you have actionable data that you can basically take back to your DNS provider and help them resolve issues much faster. Right. So we'll look at specific use cases in just a bit. This was just to provide context. And one of the things that I also wanted to talk about was regarding the data that Mehdi just spoke about a couple of minutes ago. This is about how there was discrepancy when we looked at DNS numbers from cloud nodes as opposed to what we saw from the backbone and broadband nodes, right? So basically, when you think of DNS times, there are multiple reasons why DNS can be much faster on the cloud as opposed to how it is on the backbone. The first very obvious reason is that there is a lot of noise on the network that's completely missed when you look at network components from the point of view of a cloud node as opposed to backbone. And secondly, there are a lot of companies that basically use DNS providers that are also hosted on the cloud, right? So many use Route 53 as well, for example. And then thirdly, you have cloud providers. They always typically have some business or technical partnerships with DNS providers and CDNs, right? Now, CDN and DNS providers will also have similar partnerships with ISPs and backbone providers. But in this case, when you think about it, when you see good performance numbers from a backbone, that directly translates into good user experience, right? But good performance numbers on the cloud will not and cannot reflect the same correlation, right? And finally, the takeaway from that, from the performance numbers we saw was basically that when you think about the, that particular use case where we looked at different websites, they were all from a study that was conducted in the US. It was a US data set. If you can extrapolate the same data and look at multiple geographies, for example, and countries like China, the delta there that you would see in the DNS numbers and the overall response time numbers would be much higher. So when you're actually monitoring from the cloud, you're leaving the website owner with a very false sense of security, which could be potentially quite, it could be dangerous when it comes to performance anomalies. Right. So now let's basically dive into one of the examples. The first example that I wanted to talk about is about social media tags and micro outages. So like I mentioned, we conducted multiple studies over the course of this year. And the point of that study was to identify the gaps that monitoring from the cloud was likely to bring. And here's one such example. We had a lot of websites, and one of the common themes of all of these websites is they are likely to have third-party content on their webpage. And some of the typical third-party tags that you see that repeat across all of these websites are social media tags. And here's Twitter and Facebook. These are basically, you see 4 different trend lines, and these trend lines are basically how these tags performed across all of these websites from 4 different ISPs. Right, so you see CenturyLink, Level 3, Integra Telecom, and Comcast, and these were picked up from a couple of cities. You can see how on the left, Twitter has basically a consistent line where it basically reports relatively comparable performance across all of these ISPs. But on the right, you can see that while Facebook has similar trend lines for the other 3 ISPs, on Level 3, it's basically reporting volatile performance. Right. So upon further troubleshooting, we actually realized that from just Washington, D.C. Level 3, there were peering problems that Facebook was having for quite a while, right? Like this actually lasted a few weeks. And this basically resulted in all of the websites that were actually had the Facebook tag on them being impacted by this particular peering issue. Right. So essentially, in this case, it doesn't mean that, when you see an issue like this, it doesn't mean that the Facebook tag is having an issue. It basically means that every website that has the Facebook tag on them is experiencing this issue. Right. So that sort of should show how these, how this impact is much bigger than what one would think. So monitoring from the cloud will basically mean that you're testing applications from a single vantage point. Like you could have clouds all over, in multiple cities, but performance is likely to vary not only across cities, but it's also likely to vary across ISPs within the same location, right? So testing from all available vantage points, like Mehdi mentioned, is the key to getting full visibility. And when everything is functional, your cloud monitoring data will be very comparable with your backbone monitoring data. But that's not the point of monitoring, right? The whole idea of the monitoring concept is to capture anomalies, isolate issues, and basically improve your user experience and catch issues much before your end users are impacted. So the second example that I wanted to bring up was with one of the CDN monitoring use cases that we had. So data from one of our customers basically showed a sudden increase in round trip times just from Comcast and Portland. And when we did a couple of trace routes, we realized that this particular CDN was basically routing the traffic just from Comcast Portland to some server in Philadelphia in the East Coast, right? And all of the other ISPs did well. It was just from Comcast that this anomaly was observed. So because they were actually monitoring from all these vantage points and all of these ISPs, they were able to actually take this data back to the CDN and get them to troubleshoot it and fix it. And it was immediate actionable data that was available to them. If you are just monitoring from the cloud, that would have basically just meant a lot of frustrated customer calls, and it would just basically give you a lot of questions with no answers that backbone monitoring could give you. Right. So this is one other example. And before we actually dive into the next example, I wanted to just talk about end user experience monitoring in general. Right. How do you perceive end user experience monitoring? It should ideally be like peeling off the different layers of an onion. Right. At the core, like Mehdi was talking about, you have your internal first mile monitoring at the data center level, which gives you really good data, but behind the firewall, and it helps you identify and fix issues that you have complete control over, right? But then you take a step further back and you have synthetic monitoring from the point of view of a backbone. So this is where some of the control goes away, right? You're now stepping backwards. The data is still from a clean room environment, but this data will help you, identify anomalies. It will help you find issues that are backbone related. And it will also have a direct impact on your end users, right? So if it doesn't work here, it doesn't work anywhere else as well, like Mehdi mentioned. And then you take a few more steps back, you have last mile, which obviously is added noise and shared bandwidth. And all of this, while we're talking about it, is still synthetic, which means that you're proactively probing your applications 24/7 to continuously look for issues over a period of time, right? But the puzzle is only complete when the final piece falls into it, where you completely step away and let your actual end users tell you where their pain points are, right? So this is exactly where real user monitoring comes into picture. And when you actually put all of these things together, that's when you get a complete, the whole picture, where you get like a 360-degree view of how your application and your websites are actually performing. When you're monitoring from the cloud, you're missing out on a good 3/4 of what visibility you would actually get, from all of the other vantage points that we just spoke about. I would place cloud monitoring somewhere between your internal monitoring and your backbone monitoring. And if your application is hosted on the cloud, for example, then your cloud node data and your internal monitoring data are pretty much the same thing, right? Now let's get back to this particular example. So here's an example you see from one of our customers. So they have both real user monitoring and synthetic monitoring running side by side. And what happened here is that they started to see some performance degradation from just one location, and it was from Dallas. And they started seeing that there was basically increased response times, which was then resulting in much higher web page response times, overall page load times, for just tests that were conducted in Dallas. And when we did some further troubleshooting, we realized that what was happening is that the base HTML was not basically being cached by their CDN. So whenever a request is made to the CDN, it was in turn fetching it from the origin server, and it was just from this particular location, right, like from Dallas. And soon enough, their RUM started, producing the exact same data, and you could actually see that the response times on RUM was as high as what you saw on synthetic as well. And you can see a direct correlation at the bottom right, where we could see how performance metrics directly affected the user behavior. There was a huge drop in page views at the same time, during which there was increased response times and, obviously document complete times, which govern user experience, right? So it only improved after this issue was fixed by the CDN, and their page views dropped back to normal, right? So that's a direct correlation that you can actually get using both synthetic and RUM side by side. And in the same context, there was another customer who recently ran into a very similar issue. This was an interesting example where they basically had a homegrown real user monitoring solution, and using their internal RUM data, they actually saw that there was, marked the performance degradation just from India, right? Like only Indian users were experiencing performance degradation as opposed to other countries. And they came back to us and they wanted help with further drill down with our synthetic data. So when we actually took a look at what the synthetic data was saying, we could see that there was a degradation only in DNS times, like when we looked at the network components, right? And this was again only in India. The other countries didn't have this performance degradation. And what we also did was we started drilling down by ISP. And you can see here that there are three different ISPs here. There's Airtel, Reliance, and Tata. Tata was not at all affected, but you can see there was a lot of volatile. The trend lines were much more volatile for Airtel and Reliance, right? So when we actually did some further troubleshooting, we could see that basically what happened here was that the issue was isolated to a particular subnet of IPs, where all the authoritative name servers that originated from those subnet of IPs basically failed to respond to the query when the users accessed the site from only Airtel and Reliance, right? And this we were able to isolate primarily because of the vantage points and the fact that we were able to monitor across these ISPs as well. Right, so that's basically where getting a 360-degree view and getting correlation by not only synthetic but also RUM comes into play. Right, so these are some examples, and I wanted to to wrap things up, I wanted to bring up this observation from this study that we conducted. While the overall study had many different websites from many different industries, this is an example from just a list of financial institutions that we looked at. We looked at around 19 banks, and what we did here is we basically put them all together in one bucket and looked at all of the hosts across these 19 banks, right? And we found there were 445 unique hosts across all of these 19 banks. And when we looked at each of these unique hosts separately and studied them, we saw that at least 168 of them used Amazon in one form or another, right? So imagine, like in the use case that Mehdi was mentioning, if AWS, one or more zones in Amazon in AWS had a performance issue, not only would it affect your monitoring data because your cloud nodes are hosted, your nodes are hosted on the cloud, but you'd also miss visibility into performance during such a crucial time of performance issues, right? Like you have 168 third-party hosts and probably your own that are hosted on the cloud, and you don't have monitoring data during a time when that particular cloud provider also had an issue, right? So with that as my wrap-up example, I'd like to pass it on back to Mehdi.
Thank you, Ranjana. So as somebody said, it's location, location, location. One last consideration. As I mentioned, we're moving into a digital transformation. There is complexity, etc. And then all of our customers are adopting DevOps and SRE cultures, which is great, and a huge fan of that. However, one of the things that is going to be very important to have a true DevOps and a true SRE culture is to bring also a certain level of transparency. If you listen to a lot of the SRE talks and DevOps talks from engineers at Google, etc., you'll see a lot of talks around SLAs, SLIs, service level objectives, etc. So it's very important to share the data across the company to have a true successful DevOps and SRE culture. With that in mind, it even makes it even more important to have reliable data and to make sure that the data that you collect is actionable and trustworthy. So, and it's very important as well to hold your third parties accountable, and especially your cloud providers if you're moving there. With that in mind, I think this concludes our part, and we'd love to open it up for questions.
I guess it helps if I take myself off mute. Sorry about that. Okay, guys, now it's time for questions. So if you have a question for either of our panelists today, please don't hesitate. Just use your GoToWebinar control panel and submit your questions. We'll go ahead and get started now. Is there a risk of redundancy to having both synthetic and RUM in addition to cloud? Would I be paying for data that I already have?
So the question, if I understand correctly, is there redundancy in having both real user monitoring and synthetic monitoring? The answer is no, because one of the things we notice when you just have a RUM strategy, if when you have nobody on your site, you have no data to act on. So it's extremely important to have both a proactive, which is the synthetic monitoring or active monitoring, and then passive monitoring. And it's really important to have a this dual mode of collecting data, one that is constantly probing, and then one that is relying on the end user feedback. We've seen this a lot with customers that have adopted only a RUM solution. They came back a few months later saying we were completely blind, and we need to have proactive data as well.
All right, great. Next question, what is the difference between last mile testing and RUM?
Sure. So again, last mile testing still relies on a synthetic approach or proactive approach. It's very limited still in terms of how many locations you can test from. So that's why having RUM creates such a huge universe of data that it's actually really interesting to see where all your users are coming from, which ISPs they're coming from, etc., etc. So it's one is more complete than the other in terms of coverage.
Okay, great. Just a reminder to the audience, there's plenty of time. If you have a question for Mehdi or for Ranjana, please go ahead and use your GoToWebinar control panel and submit your questions. Okay, next question. I get the need for a mix of multiple locations now, but how do you go about selecting those locations and types of monitors?
So let me rephrase the question just to make sure I understand it. So the person understands the need of multiple physical locations, and then after that sorry, can you say that again?
Sure. How do you go about selecting those locations and the types of monitors?
Oh, sure. Okay, so that's actually a great question. So a lot of our customers, they deploy a monitoring strategy that is very tied to their business needs. So a lot of customers, for example, work with their business team, their business analytics team, to understand where their traffic is coming from. So if you are mostly on East Coast traffic, you don't need to monitor from the West Coast. I mean, there is no need for that. So folks typically look at their analytics data to understand where most of their traffic comes from, what time of day, etc., etc., and that translates into a monitoring strategy that will include, okay, where do we monitor from? How often should we monitor? which ISPs we should monitor from. You can also get that data from RUM as well, right? So Google Analytics or RUM provide that same level of high-level data, although RUM is more technically driven or more suited for technical teams than Google Analytics. But you should translate your business metrics into your monitoring strategy.
Okay, all right, great. Our next question, why shouldn't I rely on cloud only for synthetic when RUM can catch performance issues caused by a cloud outage?
Sure, another great question. So one of the things you have to remember is RUM is very good at capturing all the data that you get. However, it's not very good at telling you why there is a problem. And it's definitely not good enough yet for capturing data post-document complete. So once the document or the onload event has happened, RUM is typically blind as of what happened with all the other third parties that are on your site. So you might have blockage or outages caused by third parties that you might not see. So these are the pitfalls, if you want, of RUM. That, by the way, are getting better and better, right? So we just worked with Google and released a version of our RUM product that can detect some network outages, even if you cannot make it back to your site. So that's called network error logging. It's not supported by all the other browsers besides Google yet, but hopefully the other major browsers will support that very soon. So you have to remember that RUM is still not good at capturing post-unload, and is not good at telling you why there was a DNS problem, right? So that's why you have to rely a little bit more on synthetic to answer the question of why. Then after that, as we showed with some of these examples, whether it was the example of that company that was having issues in India or whatnot, none of that data was captured by the cloud nodes that they were using, right? The answers to those questions as of why they were having problems were only collected because they had access to other vantage points on other ISPs in the different regions that they cared about. For example, if you're serving traffic mostly to London and you're relying on AWS Ireland, you might be missing a lot of issues just because Ireland and London are not the same.
All right. All right, great. So guys, there's plenty of time. If you have any questions for our panelists, please go ahead and use your GoToWebinar control panel. We have one more question that's come in. You have cloud nodes, so when do you recommend using cloud nodes for monitoring?
Sure, that's a great question. So the reason we deployed cloud nodes last year, we added 111 of them, was really to help our customers deal with a few situations. One of them was cloud migrations. So they were in the process of selecting which cloud provider was better for them. So they needed some verification points. So by, let's say, I am running a data center in Virginia, and I'm looking at actually, Virginia is a bad example. Let's say I'm running a data center in Texas, and I'm looking at the cloud provider to be my backup or something like that. Which one shall I use? So by having our nodes, our cloud nodes, they were able to do some testing from the various cloud providers that we have back to their origin data center to see which one would have the best connectivity back and forth. So that was an example, is for cloud migration. And as I mentioned earlier, if you have an application that is cloud native and you rely on third-party services from other companies that are also hosted on the cloud, it's a great way to do monitoring between the two without introducing or measuring or having the latency of the internet in the middle. So if you're, as I said, if you're using a payment gateway that is hosted on AWS and you're hosted on AWS, monitoring from AWS to AWS might make sense to not have the noise of the internet in the middle.
All right, great. Well, that was the last of the questions that we have right now. I'll give the audience another minute or two to go ahead and submit any final questions that they might have. And while we're waiting, I do want to remind the audience that today's event is being recorded. So if you missed any or all of the event, or if you just want to listen to it again, you will have the opportunity to do so. Following the event, we will be sending out an email that will include a link to access the webinar on demand. The webinar is also going to be listed on the DevOps.com website, so you can always check there for it. Just go under the webinars tab on demand and it should be right there waiting for you. The webinar is also going to be, let's see, I totally lost my train of thought there. The webinar, while you're on DevOps.com, please feel free to look around at other webinars that we have coming up and on demand. Mehdi and Ranjana, I don't see any other questions coming through, so I guess we're just going to give everybody about 15 minutes back in their day. So I do want to thank the both of you for giving such a great presentation, and I also want to thank the audience for joining me today, and also want to thank everybody who did submit questions. I appreciate that. So guys, thanks again for such a great presentation.
Thank you so much, and happy holidays and happy new year to all of you.
Thank you, and to you as well. So this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.